Okay, welcome back to our video on rate of change. Here's part 2, finishing up these last 2 examples. So now we're looking at, we've got a snowstorm going on, and Thomas measured the height of the snow in inches several times in a 12-hour period. So if we look at our axes, this X is hours since noon, so 0 to 12, that tells me this is from noon to midnight, and then our Y is the height of the snow in inches. So what is the average rate of change between 6 p.m. and midnight? So I'm going to look at 6 p.m. is here. This is the 0.64. And midnight is here. This is the 0.12. And then this is in increments of half, so 12, 0.5. So to calculate that rate of change, I'm still going to do y2 minus y1 over x2 minus x1. So that will be 0.5 minus 4 over 12 minus 6. And that is going to give me about negative 0.583 inches per hour. So what does that mean? Well, because it's negative, that means the snow is melting. So we are losing about 0.583 inches of snow every hour. It's melting. Okay, over what 2-hour interval on the graph was the height of the snow increasing at the fastest rate? So we want to know the greatest rate of change. Well, there's a couple different places where I have a positive increase. I have this little part here, and it's not linear, but we could still calculate the average rate of change. And then I have this interval here. After that, it gets kind of horizontal, which means we had a constant rate of change. So I can calculate these 2 intervals and see which one had the greatest average rate of change. So starting with the green, I've got the points 1, 1, and 0, 0. So that is going to be 1 minus 0 over 1 minus 0. So that would be 1 inch per hour. Okay, so that's for the green. Now I'm going to look at the blue and similarly calculate. So the second one, this is 3.5, 4, and then I have 1, 1 again. So 4 minus 1 over 3.5 minus 1. That is going to give me 1.2 inches per hour. And so they're both positive, so they're both increasing, but 1.2 is a greater rate than 1. So the interval where we are increasing at the fastest rate, that is from 1 p.m. to 3:30. So 1 o'clock to 3:30. Over that interval, I am increasing at the fastest rate. So at what time did the snow stop falling? Well, let's look at where we have a 0 rate of change. That means there was no more snow coming down, so that whole time, so that happens at around 3:30. And so describe how the height of the snow changes between noon and midnight. So over this entire interval, well, it starts out by increasing. So we start with a positive rate of change. So we have a positive rate of change from noon until we stop falling, the snow stops falling at 3:30. Okay, then we have no rate of change, or there is 0 rate of change. Until it starts melting at 6 p.m. And it is a negative rate of change until midnight. Great. Okay. Last one, we are going to look at some gas prices. So we are looking at the average price of gas in dollars per gallon over the interval 2010 to 2015. So what was the average rate of change from 2010 to 2014? So we are just going to still use our slope formula. So in 2010, our price was $2.84, and in 2014, our price was $3.42. So we're going to do 3.42 minus 2.84 over 2014 minus 2010. Doing those calculations, I get, and I'm going to round to 2 decimal places since we're working with money, about 0.15. So what does that mean? That means that the price of gas is increasing by about 15 cents a year. Okay, what was the average rate of change from 2010 to 2015? So I'm going to use this same point, but my other point is going to be 2015, 2.51. So I'm going to do the same calculation with my new values, 2.51 minus 2.84 over 2015 minus 2010. And here again, I'm going to round to 2 decimal places, and I get negative 0.07. So this means that on average, the price of gas was decreasing by about 7 cents per year. So those are 2 very different pieces of information that we're kind of concluding based on where we are looking for our rate of change. So what do these tell us about the gas prices between 2010 and 2015? Well, it tells us that we had a steady increase for a while, so we were increasing over an interval of time, and then we had a drop at some point. So prices were increasing, then they decreased. So if we were going to assume that the rate of change from 2011 to 2012 continues through 2025, what would we predict the price of gas to be in 2025? So we need to find the 2 prices in 2011 and 2012. In 2011, it was $3.58. In 2012, it was $3.69. So we are going to find the slope between these 2 points for the final part. So that is going to be 3.69 minus 3.58 over 2012 minus 2011. And again, I'm going to round to 2 decimal places because we're talking about money, and that is going to be positive 0.11. So what this means, again in context, is that the price of gas is increasing by about 11 cents per year. So if we want to predict the price of gas in 2011, what we need to do is figure out, well, what was the price of gas in 2010? In 2010, it was $2.84. And how many years are there between 2010 and 2025? Well, that is 15. So I'm going to be increasing by 11 cents every year for 15 years. And this is where we will get our calculation. And again, rounding to 2 decimal places because we're talking about money, that is going to be about $4.49 per gallon. That is our predicted value, and it would be different if we used a different rate of change to make that prediction. Okay, that is the end of part 2. Thanks for coming back.